Hi everyone, this is Jason, producer of DataBS. Welcome to part 2 on our interview with Kevin Hartman, Head of Partner Solution Architects in the Americas at Databricks and Lecturer for Data Science at UC Berkeley. If you haven't listened to part 1 of this episode, we highly recommend that you go and check it out. We will drop a link to part 1 in the description of this episode. If you did listen to it, we hope that you learned a lot from the conversation so far and enjoy the remainder of this interview with James and Kevin as they finish their discussion on collaboration, community, and best practices in data science. Here we go.
Welcome to DataBS, a show dedicated to tackling the big questions impacting the world of data and ML/AI without any of the BS. My name is James Weingart. Each week I sit down with guests from across the data ecosystem to unpack how they're shaping their businesses or the businesses of others through the real-world application of data engineering, ML/AI, infrastructure, analytics, and more. No fluff, unfiltered, but slightly edited to remove noise. This is DataBS. Let's get into it.
So, we talked about these clean rooms where you might be bringing in data from various parties, right? So you have let's just use Experian plus Nielsen plus your own data as like a working example for that. How can Databricks support like the lineage tracking of that data through a set of transformations into like a final artifact so that you can trace back, I actually didn't use Nielsen, or I actually didn't use Experian, or I was using Nielsen for these identifiers and I was using Experian for these identifiers. So now I'm able to have a much better understanding of like where we're sourcing different pieces of information.
Okay, that's another great question about lineage. So if you're going to do, a production system, so clean rooms is one example of like using and getting access to data in a place that is a shared environment. What was probably more typical is that once I understand what I need, I'll probably use, data that's on the marketplace outside of a clean room to productionize that. So now that I'm creating a production level asset or production level product that is leveraging this data, I'll be doing my own like transformations on my data to sort of conform to that, or conform to however I'm going to be doing my analytics, weaving in this other data from other sources. The good news is that if I'm doing work there and I'm changing dimensions or I'm changing the transformations or things like that, if you're using Unity Catalog and to do all that work, all your lineage is automatic. So everything, across queries, across languages, all the way down to sort of the column level. It also includes other attached things about that transformation, like anything that was like a notebook or a job or anything that's sort of related to running that query. That's also sort of available in your lineage view to see like, okay, well, not only did that thing change, but here's the actual code that was used when that change was made. So it's sort of really important to understand, how I can, track all this information as things might change. The challenges would occur with these external systems where you don't have that sort of tracking mechanism in place. It's not automatic. Either you accept that I'm not going to be able to kind of do that, but I, rely on sort of that source system. Or if it's a source system that also purports on lineage information, the good news is that you can begin to ingest that as well and track how that might have changed. It just takes additional work. So there's an open API. There's an API that allow you to import and ingest the lineage information from the source systems as well. It just you understand what those APIs look like and the metadata that's needed and how to conform what needs to be fed into the API to track it. But then you can have end-to-end view of every single sort of change in your ecosystem.
Yeah, so for like federated data sets, things like that, where you might have like you're actually calling a view definition, and that view is really a few tables joined together with some filtering pre-applied to it or something like that. And then you want to have context of that in the upstream or the downstream.
Right.
The side, so that you actually, I'm not actually calling like what the transactional lines are. I'm calling this other thing, right? But if that's not exposed to you, really the only people who know are the developers who work on that particular app.
Exactly. And if it's outside your organization, then you sort of need to go to that organization and say, hey, can you please provide me your, some of your change information that I need to get access to? I mean, there may not be a problem you need to solve for it, honestly. Usually
it just depends on the problem statement, right?
Yeah. It really depends. Usually, like outside sources keep a fairly unified data description of what they're providing to you. And if they are going to change that, usually there's a version for that that you would say, oh no, I just need the old version of that, like, because that's the data that I need to, that's the contract they have.
Yeah, an example like situation I can imagine is like you don't realize you have some PII coming over because whatever, it's got a weird name. You don't know the name. Like, you live in the US and it's like the Japanese ID number, right? And I don't know what that's called off the top of my head, but I know that that's like a piece of PII. And if you're doing, I don't know, some finance related thing, and then like that type of information comes into your model, which is not, depending on the use case, isn't really allowed to happen. And then out of nowhere, you have like bias that would technically be illegal introduced to your model. So you kind of have to go all the way to the like very raw data and make sure that you're not bringing in, any of these like protected class information where you can't like bring it into the model.
Also in the platform, it's part of like the sort of the data intelligence and engine and detecting and looking and doing some observability. There are actually built-in tool sets to sort of automatically detect pi, right? Now, maybe not in your case where you described the nuances between like a Japanese sort of equivalent and an ID, but sense information can almost become auto-detected, at least in a sense, and then alerted to you to sort of do something with that, whether or not to go back and protect it or not.
Yeah, I actually only happen to know about this Japanese ID number because of some data loss prevention tooling. So I know that that's like on the list somewhere. Yeah. Okay, so yeah, one of the things you were talking about earlier is like these open, because Unity Catalog is open source. You talked about these open API specifications for Unity Catalog for you to ingest, various metadata information such as lineage and things like that. So I think that kind of segues pretty well into like choice of open source tooling. Like Databricks is at a position where they can just build their open source tooling and use that as part of like their solution. But, if you're advising somebody, maybe not even within the scope of Databricks, like how do you help them evaluate and decide like which open source frameworks they should integrate into their stack?
So there's a couple things there around open source, and yes, it's part of Databricks' philosophy. It's core to our belief system is to make sure that you rely on open standards, right? That's sort of our first level position. And boy, I can go in a couple of different directions with this. But let me answer your question first about choice of open standards or what open source system. So even before joining Databricks, I've been a practitioner, and my own philosophy has always been I want to leverage things that are going to be driven by the community or embraced by the community. So that's the things that you're going to look for when you're choosing open source tooling. Like, how big of an ecosystem is it? Is it actively contributed? When's the last sort of, pull request and commit? If it's active, right, and you've got a lot of people who are contributing and it's evolving, that's a pretty good candidate, like for selection as to what tool I might want to use. Because I now understand that it's not just me who is going to be developing and using this, but it's also a whole community of people who will. And it also helps my organization, right? Because if we're looking for assistance and help other practitioners to develop something, well, it's much harder to find someone off the street that might know information around a proprietary system than it is to understand, and look for people who have been involved in the community at large and know about the open source or open standards that are there and know how to develop towards them. So that's really important consideration. But then, of course, you need to consider other things about the tooling. Is this solution going to scale for my needs? What is it that I'm going to be using this tool for? Those are other important considerations to sort of factor into your selection. But then going back into like where my mind was going when you asked the question around open source and Databricks philosophy and why we sort of have that position, it's also because we embrace the community at large for your choice of tooling. And the way that we think about this is we don't think you should get locked in to proprietary solutions. And that's why things like the Lakehouse advent, came to fruition, because it's sort of more community inspired, community led, built on open standards. So now it's sort of been adopted, but we still believe that you should continue that journey and leverage, things like simple storage, like from your data lakes, and put on top of that, now a governance system, which is in the catalog. But before that was just a Delta format, an open standard protocol that allowed you to treat your data lakes in a way that to support ACID transactions, right? So then you've got the key ingredients, right, to support what a data warehouse would support, but built on open standards, so that I'm now I can do all the same things outside of a proprietary sort of approach, so that the community at large can support that. So sort of tying those things together, our belief system is that open standards is really, high in that list. And then providing services then around those open standards is sort of where we position, the tooling and the product and things like that. Don't lock someone in, but use the tools of choice and the best tools that you have out there, agreeing upon an open standard and open format.
Major benefit of Databricks is you can do it all in one spot, right? That's really what it boils down to for me, is that I don't have to bring in another tool. I don't have to think about it. I just do the thing within Databricks and I move on with my life.
Yes, you can, but you have choices too. So you're using Databricks because it provides the most fast and efficient sort of way for you, right, to get your workloads done. But you still own your data.
Yeah, I mean, you're writing the data into Delta format at the end of the day, right? And Delta format, I don't know. I want to query a table with DuckDB or something.
You can do that.
And a Lambda function, but because the data volume's pretty small for that particular table.
And you don't have to turn on your data, right? Turn on compute to get to your data, right? In the way that some other systems sort of actually have you sort of move your data in there into proprietary system. And once you do that, okay, now I need to query it. Okay, well, let's turn it on then, right? Oh, really? Okay, sure.
And that's my only option at that point, right?
Yeah, you're right. And then if you want to run analytics on that, and you want to share that with someone, let's say you want to share that data, outside of your environment, you got to turn on your compute. Whereas the way that we sort of approach that is you sort of turn on the compute at the place that you need it, the data is there.
Well, somebody has to turn on their compute. If you're doing a share from some other systems, just somebody's responsible for compute. But that compute is tied into that ecosystem, that vendor ecosystem.
Right.
So you can't do, something use a different query execution engine, kind of in the default setting there, which is vendor lock-in, right? And how does vendor lock-in create things? So actually, I think this segues into the next kind of base question that we had wrote, which was about interop between open source tooling and proprietary tooling. So when we have this open source formats and things like that, which allows a lot of flexibility, and then Databricks' data intelligence platform kind of is basically a bunch of glue across these open source tooling that for the most part Databricks has built up. But you have these proprietary systems that you have to go talk to for various reasons, SAP is probably a good example here. A lot of the large organizations have a lot of their business data in SAP. Mm-hmm. SAP is a gigantic ERP that holds purchasing agreements, invoices, all these things that a lot of people care about, if you're doing a forecasting flow. But Databricks has to kind of allow the interop between, those different systems. And so what are the challenges that you have in that situation?
So to help, address those challenges between, Databricks and those proprietary systems, a way forward is to rely on our ecosystem of connectors. There's a huge number of ISVs and partners who have built those connectors for you to integrate with, say, SAP's environments or others, or Salesforce data. That is also something that we support in something called MLflow Connect. It's another sort of set of tooling that is more native, it works sort of out of the box. So there's a whole host of sort of solutions that are available to you. You want to lean on some of those ready-made connectors so that you're not creating custom solutions as best that you can. Now, that's not going to be the case for everything, but for some of the big ones that are out there, the more obvious sort of connection needs, rely on that ecosystem, right, to fulfill sort of that piece. For organizations that may have already gone down a pathway of creating a data lakehouse themselves, and then maybe it's in a different format, maybe it's using Hudi or maybe it's using Iceberg. So to solve for that, what Databricks has done is we've introduced something called Delta Uniform, and that sort of sits on top of the different sort of protocols to treat them all in a uniform way, like uniformly, so that you can speak through the transformation layer and perform a query, and it just runs through directly onto your Iceberg tables or directly onto your Hudi tables, right?
It's like middleware.
Exactly. So and then other things for the connectors using Lakehouse, you still, if it's a source system and you want to federate and you want to govern, you can still do that, like through Unity Catalog as well, through using Lakehouse Federation. And you can also do things like with catalog federation, so leveraging maybe a catalog that exists in AWS or other places. You can use catalog federation as well to sort of promote that catalog description and make it available into Unity Catalog as well. And then it's just that there's going to be some needs even from taking information from Unity Catalog, making that available to some other system. That is also supported through open APIs, and Unity Catalog is an open source technology now too.
We talked about these proprietary systems and how do you create an integration between the proprietary system and like an open source system. Most of Databricks is open source, and so I think another piece of that puzzle that we should talk about is legacy system migration into Databricks or modern data platform, etc. And then there's also like a lot of downtime minimization you have to do in these types of workflows. So could you kind of walk us through what a Netezza takeout might look like for Databricks?
So it's a great question. So how do we approach that? Our approach, I should say, our strategy includes a phased end-to-end migration process. So it's a structured set of phases to approach your migration, which would first include the start with a discovery, an assessment, and then developing a strategy, going into a production pilot, and then going through and concluding with the rest of your execution phases. So the pre-migration is helpful in understanding your current data landscape. Like where could I have potential issues? How do I plan and prepare for secure access control when I'm moving things over? Right, so this helps me in anticipating and preventing issues that could cause potential downtime, later. And then what we would move to is a production pilot, right? So we're taking a specific use case or a handful of use cases, and we're testing our migration strategy. And this, again, it gets us more information. It helps us to understand and identify potential issues in an environment that's controlled and then inspected before going forward with a full migration. It's also helpful for us to say, okay, we need stakeholder investment and buy-in and participation, and it allows someone to see, oh, this is what it's going to look like, right? So we're sort of addressing some of the people process changes as well when we get to the final end state. It also potentially will generate excitement, right? Because like, oh, this is really, really cool. Why can we go faster? Can I get more people on this? Can I accelerate this, because this is going to be really, really important as I move forward. So running production pilot is key for a number of different interests. And then once I start this journey, if I'm running a production pilot, I would like to profile and see and look and leverage some automated sort of code conversion tools to help me with my migration process. And I would want to do that first, inspect how that's going to perform in that pilot mode. And what these tools do is they help to convert some legacy code, like sort procedures, ETL scripts to Databricks SQL equivalents, and ensure that your business rules are preserved. And using tools like this can help with like up to 80% of your sort of migration work, and then reserving some of the rest that might be a little more tighter or harder to resolve. More of the complex sort of queries are done as the rest. All right. So other things to sort of consider in this process is like doing parallel testing, right? And using data reconciliation tools to sort of discover, do my results match up? Are my expectations sort of matched up? And then having those things in place as part of your, general data quality checks, right? Those become interesting then later, for downstream data preparation to ensure that, hey, am I running into some interesting data quality challenges, later on? So you're sort of thinking about those as part of like in development of your parallel testing. And then once all that concludes, you're going into like post-migration and support and monitoring and leveraging our platform, you can do a lot of that monitoring and observability and looking for things before they become problems. So that's sort of like an end-to-end, just sort of complete view. You kind of want to consider doing this in phases, though, right? So that you sort of take, along with sort of starting that pilot to kind of like, okay, what's sort of the next level of use cases that I want to support, and moving to get to the things that are going to be delivering on the most value for you, fast and first, and setting up your plan, that way. And the other thing I would recommend is this could be challenging, and we would of course, speaking to like who I get involved with and who I support, Databricks, is to really leverage the power and capability of those consulting and SI partners that have done this before, and leverage that expertise of the SIs. That they bring a lot of deep industry knowledge. They've done this multiple times, and they can bring a technical proficiency to the process, that things that they've seen that you may not have seen before if you're going this alone.
So what's your philosophy on community building? Because I see a lot of it kind of through our interactions with each other.
So community building for me is shared passions in this space. So it goes deep for me. It goes before Berkeley, before like as a practitioner in sort of software construction and consulting. That's been my career, is 30 plus years in creating solutions for customers, for clients, and really sort of putting myself in their shoes, as well as like how I would want my system to be built, but also like to take pride of what had been delivered and how that solution is really impacting the customer or the stakeholder. But you also want your system or your thing that you developed to have shelf life and to be supported and to be maintained. So all those sorts of things are sort of baked into that philosophy of making sure that not only is the customer happy, but you've got like a maintainable solution consistent with sort of the open standards and open protocols and open source. That really sort of drives my desire to sort of be in this community and do community building, is because I believe that we're all at our heart, like we want to be good practitioners, right? And this is sort of a really packed thing. Good practitioners, but also responsible practitioners in a number of different fronts. Responsible meaning I want the solution to be maintainable and things like that. But also what we do happen to know in our field and what we have done in data science is to be, responsible citizens as well, and to have an eye out for what we should and shouldn't do, right? So there's some of that sort of aspects as to like, just because we can build it doesn't mean we should. This is sort of going back to some data science philosophical sort of questions too. But all those things are sort of like, baked in. You don't necessarily know the answers to some of those things without community. So you sort of rely on community to help support, one another, to test your own knowledge, but also to test your own philosophy, right? So that's why, being involved in this space, it's, going back to this early thing around, having data silos. I don't want to be people silos either. Like we should not be, like we should be, a community. So that's sort of what, goes back to, all the things that, I've been involved in and continue to actively promote. You mentioned the, the LMOps initiative that we're starting with as a grassroots thing, involving multiple stakeholders, different people from different walks of life, from industry, from academia, from our own, internal, developers. But it gives people a chance to sort of, work together, and it's cross-community, it's cross-collaborative, cross-domain, right? And that's where innovation happens too. It might be sort of going in different sort of loose threads, but it's sort of they all tie together. Innovation is also part of this too. You don't get to innovation without involving multiple people. You don't get to the same level of epiphany when you don't get to talk to people about their needs and their motivations, and then helping to drive and move us forward.
I think it's kind of like sports in a way, where like if you need to practice with people who are roughly at the same level or nearby, because it forces you to do more, forces you to kind of reach the next step. And then when you got a bunch of people, right, everybody's feeding off each other. Like, oh, I didn't think about like that use case because I work in my little bubble over here.
It is contagious, right? It's really contagious, and it's fun. There's a definite spark and light when you're working with like-minded people, like this conversation that we had today. It's just fun, right? Because this is sort of the space that we live and we get to talk about, like, really. And boy, it's like with my job, like the things I get to do. This is recorded, but maybe we should cut this part out, right? Oh, really? You want to pay me to do what I get to do? Like, that's awesome,
Yeah, but I mean, like, that's the type of people that like companies want to hire people like that anyways, right? Because you know that if somebody really is about something, then you know that they're going to do good work. It's inherent to like, yeah, if there is passion, people will do good work. You know, like it's just inherent to the process, right? Like if somebody doesn't like what they do, it's clock in, clock out. I'm doing exactly what I'm told, nothing more, maybe even less.
Yeah.
You know, because you don't enjoy it, right? It's a suffering. And a lot of people get stuck in a world where they have to do a job they hate, and it's painful.
It can be. But there's a path for you. Seek out people who could inspire you to get beyond maybe that local proximity or the local thing that you're sort of stuck in.
Yeah. And working with other people is really important, right? Also, like, people quit their manager, not the company, typically, right? So, you know, when you look at what does that mean? It's like people care more about the people they're around than the whole organization, right? I guess it's the people who have bad interactions with their manager, right? That's what really stops them from being happy.
It's true. And luckily, you know, I work for an organization where that, what we talked about with the community, that's the culture, right? And that's goes up and down, like to the executive level. You know, Ali, Mate, they're also professors, adjuncts, and they're also practitioners. And in this space, like, they know it. So when they're having conversations with them, they can kind of go up and down and navigate. It's so cool.
It's really interesting about Databricks in particular from the executive team, because the vast majority of the executive team came from academia, kind of like they chose their roles based off of like what they kind of fell into during the early days, but they were all professors or grad students and things like that before. And so they all contribute to the community. Like this, it started as an open source project, really, right? Like interesting idea about, you know, Spark, where it's like, what if I relax the memory sharing just a little bit, right? Like, yeah, that one idea now is like evolved. You know, it's been, I don't know, I think it's 2004 or something like that. Right, 20 years of like just evolution of this idea started with like just a simple idea, right?
There's a nugget before, yep. And then the team surrounded it, and they developed it, and I think 2013 I think is when the company became a company. I believe that's when Spark was also open source, put out. So around that time frame, so don't quote me. The idea has just preceded that, but the company itself was just fairly new. Right. It was a research project for a good long time before it got to a state where both the community was active, Spark, Apache, it was donated to Apache.
Probably 2011, 2012 timeframe. Like the idea comes in, and then they build up that idea, and then, you know, got Databricks, 15 years.
Yes. And it's one of the most heavily contributed open source initiatives around. And that it's a continuation of that philosophy that Databricks does. It's like taking something that may have been developed internally and open sourcing it. Delta format, open source. Unity catalog, open source. MLflow, open source. There'll be more. There'll be more innovations that'll be coming, and those will be open source too.
Yeah, and there's also just like the evolution of Spark itself from, you know, just RDDs, resilient distributed data sets, to data frame, structured stream, Catalyst engine. Like there's a whole lot of innovation just on top of the engine itself.
Right. Yeah. Photon. There's a lot of innovation that has been occurring behind the scenes, making that sort of seamless though for customers of this.
You don't have to think about it. Okay. So Kevin, where can people learn more about Kevin and Databricks?
Well, with Databricks, there's a website that's a lot of information about Databricks can be found there. I'd also be happy to talk again at any time if you're more curious about what Databricks can offer to you or others that are maybe listening. About me, so I guess I should share that I'm coming up to be included in a registry Who's Who in America, and I'll be featured in a Who's Who of industry leaders. So that's coming out soon. So if you really want to know more about me, about my bio and background, more about my philosophy, that'll be there forthcoming. But also just, reaching out or finding out more about me on LinkedIn. Happy to connect and talk with anyone about, what I get to do in Databricks and sort of philosophy on data science, Gen AI, other things. Happy to, connect and talk more about that.
Awesome, Kevin. Well, it was great to talk to you. Hope you have a great day.
You too. Thank you, James.
That's it for this episode of Data BS. If you enjoyed this episode, make sure you subscribe wherever you listen to your podcast and not miss the next one. This episode was sponsored by Cordine, a data consultancy that helps organizations unlock the power of their data. If you have a data challenge, we can help. Visit Cordine.com, CORRDYN.com to learn more. See you next time.